Okay, welcome. And now we're going to introduce the first corollary to the mean value theorem. So corollary is a result that comes from the mean value theorem. So theorem, we're going to call this theorem 3 or corollary 1. It says functions with derivatives at equal to a derivative of 0. Okay? And we should know what that means, right? It just means that it's constant. So, but what does theorem 3 say? It says let f be differentiable over an interval I if f prime of x equals 0 for all x in the interval I, then f of x is constant for all values of x and I. Okay, so it seems trivial, but it's important. It's an important result. So let's prove it, okay? Now, the proof is done by what's called a proof by contradiction. What is proof by contradiction? Proof by contradiction is where you assume the opposite of what you want to show. Okay? So you assume the opposite of what you want to prove, and then show that by that assumption it leads to a contradiction, and by basically proving that the opposite must be true. Okay, so that's what we're going to do. So we're going to suppose, okay, so first of all, since f is differentiable over I, it is also continuous. Over I, right? So that should be obvious. We talked about that before. Now, let's suppose, so here's our assumption, let's suppose f of x is not constant for all x in I. So suppose f of x is not constant. So that's what we're trying to prove. We're trying to prove that f of x is constant, but let's assume that it isn't. Let's suppose that f of x is not constant for all x in I. Okay. If that's the case, then there has to exist, right? So then there exists AB in I such that f of A is not equal to f of B, right? Because if it's not a constant function, then there has to exist A and B in the interval such that f of A is not equal to f of B. Okay? So now we're going to choose notation so that A is less than B, okay? Okay, so if it's, oh, hold on a second. Oh, I forgot. One little piece. So there exists A and B in I where A is not equal to B. Okay? Forgot that. That's something we need to know. So where A is not equal to B such that f of A is not equal to f of B. Okay, there we go. Now, let's choose A is less than B. Okay, so we're going to choose, let's just choose A is less than B. We could do it for A is greater than B, but let's choose notation so that A is less than B. Okay? Therefore, what happens? Well, f of A minus, f of B minus f of A divided by B minus A is not equal to 0. Right? And since f is differentiable, right, on the interval I, right, it's a differentiable function, by the mean value theorem, there must be a C in the interval, right? There must be a C. There must exist C in I such that what? That the f prime of C, right? F prime of C is equal to this. F of B minus f of A, not B of A, f of A over B minus A. Now, so look, since this is not equal to 0, and by the mean value theorem, this must be true, that means what? Therefore, f prime of C is not equal to 0. Which leads to a contradiction. Because it contradicts our original assumption, which was that f of x is not constant for all x and I. But we just said, well, if that's the case, there must exist an A and a B, right? Where A is not equal to B, where f of A is not equal to f of B, right? But that led to a contradiction. Hold on a second here. Something doesn't make sense there. That does not make sense. What am I missing? Why is that a contradiction? Oh, right. Okay, I see. Because we're assuming, right, part of the assumptions here is that f prime of x is equal to 0 for all x in I. And that's where the contradiction occurs, right? So we assumed that it wasn't constant for all x in the interval. And so by that assumption, we went through and we found this, right? And then by the mean value theorem, we conclude that, which then these together, we conclude this. But that violates or contradicts our assumption that f prime of x is 0 for all x in the interval. And therefore, our original assumption is incorrect, and we conclude that f of x is constant for all x in I. Okay, sorry it took me a little while. I was trying to find where the contradiction was. I thought we were going back to this, but then I realized that it's this assumption here that it's contradicting. Okay, and since it contradicts this assumption, then the original assumption that we made, which was the fact that the assumption that f of x is not constant for all values of x, then that assumption was incorrect, and so we get our final result. And that's it. Have a great day.